Hey everyone, it's Mr. Fransky. Today we're going to be talking about derivatives. Derivatives are a calculus topic. And we're just going to do a little intro today. It's going to build on what we've been learning about limits. And hopefully it's going to make some sense about what a derivative is and how we find the slopes of tangent lines. So let's take a look. So why is this important? So let's say you're driving down Highway 100, and this might be something that you've seen in physics before, but if you haven't, I don't think it's that hard. So if you cover 500 feet in 20 seconds, what is your average speed? Well, if you go 500 feet in 20 seconds, if you do 500 divided by 20, I believe that is 25 feet per second, because there are 5 20s in every 100, so 5 times 5, 25, right? So feet per second, it's a rate, right? So we call it the rate of change. But it's an average speed, right? Going 500 feet in 20 seconds, so 25 feet per second. So the question I would ask is, do you have to go at that speed the whole time? Well, no. You could have gone like 30 feet per second part of the time, 20 feet per second part of the time. You could have been going no speed at all for a little while, and then you'd go really far in the last 10 seconds, something like that, right? But all that matters is that you covered those 500 feet in those 20 seconds. So if you were to graph this, so like if you're at zero, you have to be at 500. By the time you get to 20, but how you get from here to here is, it could be like this, could be like this. Like I said, it could be 0 for a while, and then you increase really fast. But as long as you get to that point at the end, that's what's happening. So the question I ask is, what does your speedometer tell you? Your speedometer does not tell you average speed, right? If it told you average speed, then it'd be really easy to get out of speeding tickets, because you could sit still for a long time, and then you could say, well, my average speed has come down, so I'm not speeding, right? But your speedometer tells you what's called instantaneous speed. Okay, and we're going to kind of flesh out more what that means in a little bit. But it tells you instantaneous speed as opposed to average speed, right? Average speed and instantaneous speed are different. Average speed is how far do you go over a given period of time. Instantaneous speed is how fast am I going right now. And we're going to see that that's kind of a difficult question to answer. So a little bit more mathy, a bit more mathy, not a big more mathy, sorry. Your distance traveled is modeled by S of t equals t squared, where t is measured in feet and t is measured in seconds. So we're going to find our average speed at a few different spots. So if we were to graph this, t squared is a parabola, right? So it'll look kind of like this. And don't really want to think about negative time, right? But make a parabola like that. So we got s and t. So from 0 to 4. So we go to 1, 2, 3, 4. At 4, we should be up here at 4, comma 16. And here we're at 0, 0. So how far do we go in those 4 seconds? We go from 0 to 16. So 16 minus 0. And we divide by the time elapsed, which is 4 minus 0. So 16 divided by 4 is 4. Now what do we really just calculate there? If I draw a line in here, if we calculate, we change in y over change in x, right? This is the slope. Okay, and it makes sense because you're doing the change in y divided by change in x. You're doing the change in distance, feet, divided by change in time, which is seconds, feet per second. So from 1 to 3, similar idea. Draw the graph again, maybe. Here's 1, here's 3. I want to know the slope between those 2 points. I think it should be a little bit shallower. Okay, so if I do s of 3 minus s of 1 divided by 3 minus 1, I'm just calculating the slope. S of 3 is 9. Minus 1 divided by 2, 8 over 2, 4. I guess it's the same. Interesting. Okay. Alright, let's do the next one. 2 to 7. So it's going to be 7 squared, which is 49, minus 2 squared, which is 4, divided by 5, I guess. So that is 45 over 5, which is 9 feet per second. And that makes sense to me because the further to the right you get, the faster you're going to be going, because you're covering more distance in the same amount of time. So you're at 9 feet per second there. So now, if you ask like a speedometer question, how fast are you going at t equals 1? Why is this different and why is it tricky? Well, we think about the graph. Here's t equals 1. When we go like from 1 to 3, there's a slope you can calculate, right? 1 to 2, there's a slope you can calculate. But right at 1, what's the problem with having 1 point and asking for a slope? Well, you can't calculate the slope when there's 1 point, right? If you do like 1 minus 1 divided by 0, that gives you 0 over 0, which is undefined. That's a problem, because this is a problem that comes up a lot, all the time in calculus. Calculus is kind of based on this idea, but we have to somehow be able to figure out what's going on here. And really what we're doing, I'm going to draw up a little better graph here, is what we're going to do at this point is we're going to say, okay, well, let's calculate the average speed from like 1 to, we went from 1 to 3 before, let's say we were doing like 1 to 4. Is that going to be too much or too little compared to the actual speed at 1? I think it's going to be too fast, right? Because from 1 to 4, you cover a lot more ground. So how can you do better? Well, 1 to 3 is going to be a little bit shallower. 1 to 2 is going to be even shallower. And if you can kind of see what's going on here, what we're doing is we want to get that value closer and closer and closer into 1. So really what I want to do is I want to squeeze the right-hand side of this closer and closer to 1. And really what we're aiming for is the slope of what's called the tangent line. So that would be the slope of this line right here. Okay, so tangent line just kind of bounces off the curve. It doesn't go through 2 points, just goes through at 1 point. I can draw a better tangent line if I do a little steeper curve, something like this. So tangent line just kind of bounces off. It doesn't have 2 points, but the idea is that you kind of start from further away with what's called a secant line, and then you get being that point closer and closer and closer until you end up with the tangent line, which is just going through at 1 point. Okay, so a little bit of vocab there. A secant line goes through 2 points of a function. This is a secant line. Okay, and a tangent line just kind of bounces off as a tangent line. And we use a limit of a secant line in order to find the tangent. So instantaneous speed. Let's talk about what instantaneous speed means. So instantaneous speed, this is going to be the slope of the line tangent to the distance curve, the distance graph. Okay, so average speed, you need 2 points. Average speed, you need 2 points. So what's the average speed between t equals 0 and t equals 5, something like that. If they ask for instantaneous speed, we have to somehow be able to figure out what's going on here. And what's happening is, like I said before, if you want to know the instantaneous speed at this point 1, you're going to start with the secant line, far away, and you're going to bring that point closer and closer and closer, and eventually you're going to end up with the slope of that tangent line. Cool. So this is where derivative comes into play. The derivative of a function f of x at x equals a is the slope of the line tangent to f of x at the point x equals a. It is denoted by f prime. We'd read this f prime. Okay, f prime of a. And it's calculated, f prime of a is equal to the limit as x approaches a, f of x minus x, f of a over x minus a. This is just slope. Okay, so we're doing here, we're trying to do, I'm going to draw it a little bit differently than before, which is fine. So if I want to know the slope of the function, now I don't like that function. Let's just do it like this. Okay, so if I want to know the slope at a, what I do is I go out a little bit further to x. And I calculate the slope between those 2 points. The slope of that line is equal to this function, right? F of x minus f of a over x minus a, because f of x would be up here. F of a would be down here. So I'm just doing the change in y divided by the change in x. It's the slope. Now what we do is we make the x get closer and closer and closer to a. So like if it's here, now that slope is going to be a little bit closer to the slope of the tangent line, right? If I make it even closer, it's going to be even better. And eventually I get close to, let's use some technology here. I'm aiming for the slope of that tangent line that just bounces off the curve, right? Because the closer x gets, the closer it's going to get to that value that I want, right? So that limit, the closest that x gets, is going to give you the slope of that tangent line. And you'll notice if you just do the simple thing, if you just change the x's to a's, right? Or the a's to x's, either way, what's going to happen is you'll have 0 over 0. You will always get 0 over 0. Okay, and that means that you're going to have to do more work. We're going to have to do things like factor, right? All the stuff we did when we were learning limits. So you have to factor, you might have to multiply by a conjugate. You might have to find common denominators. Okay, all our algebra tricks that we've used with limits before, you're going to have to use on all of these derivative functions. So, second more useful equation. So, this guy, what we're going to do here now is you can do a little bit easier algebra if you change up the equation a little bit. So what I'm going to do here is I'm going to say this is x, and I'm going to go to the right a little bit. I'm going to call it x plus h. Okay, so h is the distance between here, right? That distance right there is h. And so now, if I think about these 2 points, right here we're going to have f of x, and up here we're going to have f of x plus h. So if I calculate the slope of that secant line that goes through those 2 points, the slope there is going to be f of x plus h minus f of x, that's a change in y, right? That's the difference in the function values, divided by x plus h minus x, which is just h, right? So change in y over change in x. And the derivative then, f prime of x, is going to be limit as h approaches 0, f of x plus h minus f of x divided by h. Okay. That is the fancy formula for derivatives. So if you want to know the derivative at a specific point, f prime of a, limit as h approaches 0, f of a plus h minus f of a over h. We're going to do a lot of examples with this, where we're actually trying to find the slope of the tangent line at a specific point. Okay. So let's do some practice with notation. Because function notation here, sometimes people get confused with how to plug this in, and then we'll do the examples with the actual derivatives. So if we're given some different functions here, we want to find f of 3 plus h and f of x plus h for each function. So if f of x is x squared, f of 3 plus h then, right, I just replace the x, because if I do like f of 2, you do 2 squared, right? So if I do f of 3 plus h, it's going to be 3 plus h quantity squared. If you FOIL that out, 9 plus 6h plus h squared. That's one of our common factor, our common FOILs. First thing squared plus 2 times the first times the second plus the second thing squared, right? You could write it out and FOIL it though if you want to do 3 plus h and 3 plus h. Next one we got x cubed. So, sorry, I didn't do x plus h. So f of x plus h would be x plus h squared, which would be x squared plus 2xh plus h squared. Okay. Next one we're cubing. So f of 3 plus h is going to be 3 plus h cubed. And you may not know this one. It's the first thing cubed. It kind of uses Pascal's triangle. Plus 3 times 3 squared times h. Plus 3 times h squared plus h cubed. I'm not going to expand that out. But you could also do that just by doing 3 plus h 3 times, right? And just FOIL it. FOIL the first two and then multiply by 3 plus h again. That'd be just fine. Basically, coefficients here are 1, 3, 3, 1. And then the 3 goes from cubed to squared to 1, and there's not any at all. And the h builds up from nothing to 1 to 2 to 3. F of x plus h. X plus h cubed. Which, if you factor it out, x cubed plus 3x squared h plus 3xh squared plus h cubed. So again, 1, 3, 3, 1 for those coefficients. If you don't know Pascal's triangle, no big deal. I talk about it more in the derivative tricks video if you want to watch that. Next up we got 1 over x. So f of 3 plus h can be 1 over 3 plus h. F of x plus h can be 1 over x plus h. Root x, square root 3 plus h, all underneath. Square root x plus h. 2x squared minus 3x plus 1. So this is kind of the one where people start to get confused a little bit. You replace both x's, right? So it's going to be 3 plus h squared minus 3 times 3 plus h plus 1. And then if you FOILed it out, it would be 2 times 9 plus 6h plus h squared minus, I'll leave this 3 times 3 plus h plus 1. Right, and then you can distribute the 2. But the important thing is that you know you have to square the 3 and the h, and then you can distribute the 2 after. So x plus h, same deal, right? 2 times x plus h squared minus 3 times x plus h plus 1. And then you could FOIL that out as well. But you get the idea with the notation now, hopefully. Alright, so back to our speed problem. Let's actually do an example now. So if s of t is t squared, find the instantaneous speed at t equals 1. In other words, compute the derivative, or s prime, of 1. So computing the derivative at 1. So we should put it in our formula. Limit as h approaches 0, f of a is 1. So I'm going to do 1 plus h minus f of 1 divided by h. I always write this out every time. Okay, you'll see in all the 3 examples I'm going to do here, I'm going to write this out. So now we plug it in. So it's the limit as h approaches 0. F of 1 plus h. So I'm plugging 1 plus h in, so it's going to be 1 plus h squared minus 1 squared divided by h. That's the limit as h approaches 0. 1 plus 2h plus h squared minus 1 divided by h. 1's cancel. And now the top, they both have an h. I'm going to pull out an h. This always happens. You will always somehow be able to cancel an h, because if you can't, you'll always have 0 over 0. So after the h is canceled, I call that the magic step. Because now, you don't have a problem with the h anymore, right? This is still limit as h approaches 0. Now we can plug in 0 for h. And what do we get? Plug the 0 in for h right there, and we get 2. So what does that mean? That means at time t equals 1, you're moving exactly 2 feet per second. That is your instantaneous speed. Okay? Alright, let's do another one. So you got 1 over x, computing f prime of 3. So that's going to be the limit as h approaches 0. F of 3 plus h minus f of 3. You're going to get so tired of writing this, you're going to be able to do it in your sleep. Divided by h. So we have limit as h approaches 0. This is where the algebra comes into play. 1 over 3 plus h, that's f of 3 plus h, minus f of 3, which is 1/3, divided by h. Now we got to do common denominator. So these share nothing in common, so I have to do 3 plus h here, 3 plus h. Over here I have a 3 and a 3. So it looks like I'm going to have limit as h approaches 0. 3 over 3 times 3 plus h, minus 3 plus h over 3 times 3 plus h, all divided by h. And this is one spot where dividing by h, I think it gets confusing, so I'm just going to multiply by 1 over h instead. Okay, so I'm just basically slid this entire thing off. Slid the entire thing off, and I multiply by 1 plus h instead of dividing by h. Let's come over here. So this now I can combine the top, right? So the limit is h approaches 0. Now I know all of you would distribute that negative accurately across the top because it's a fraction. When you subtract a fraction, you have to subtract the entire numerator. So I'd have 3 minus parentheses 3 plus h divided by 3 times 3 plus h times 1 over h. Don't drop this h. A lot of times people will forget about it. They'll only deal with the numerator and forget about the denominator. So that is limit as h approaches 0. This negative distributes. The 3's cancel. I have a negative h. Do not lose that negative sign. So many people do. Okay? But you distribute the negative. So we have over 3 times 3 plus h times 1 over h. Those h's cancel. I'm left with a negative 1 upstairs. So I have limit as h approaches 0. That was our magic step because the h is canceled. So we have negative 1 over 3 times 3 plus h. Now you can plug in 0 for h without a problem. We end up with negative 1/9. So let's review what that means. That means if you were to graph 1 over x, which looks like this, if you go out to 3, right there, the slope of that tangent line is negative 1/9. Okay. All right. Next up, we got root x. We're going to compute f prime of 4. So we're going to do limit h approaches 0, f of x plus h minus f of 4 plus h, because we're going to get 4, minus f of 4 divided by h. That is a limit as h approaches 0. Square root of 4 plus h minus the square root of 4, which is 2, divided by h. Looks like we need a conjugate here. So I multiply by root 4 plus h plus 2 over root 4 plus h plus 2. So I'm not changing anything, just multiplying by 1. The bottom I am going to leave factored. I am not going to distribute in the h, because if you do, it gets lost. And our goal is to cancel the h, so I'm going to leave it outside. So limit is 0. So on the bottom, we'll still have h times root 4 plus h plus 2. Parentheses important there because it'd be distributed. On the top, multiplying by the conjugate, we get root 4 plus h, and root 4 plus h is just 4 plus h. The outside and inside terms will cancel. That's the whole idea of multiplying by the conjugate. The outside we get 2 root 4 plus h, inside negative 2 root 4 plus h. So they cancel. But then the last two terms, I get a minus 4. So it looks like those 4's go away. So we now have limit as h approaches 0. Just h on the top divided by h times root 4 plus h plus 2. So notice this is why I left it factored out there, because now the h is canceled. So this is the limit as h approaches 0, 1 over root 4 plus h plus 2. So that was my magic step. Now I can plug in 0 for h without a problem. So that is 1 over root 4 plus 2, which is 1 over 2 plus 2. It's 1/4. Awesome. All right, last thing I'm going to talk about here is using derivative as a function. So what you may have noticed, these limits, they take a little bit of time, right? The last 3 limits we did, right? You have to do this f of a plus h every time minus f of a divided by h. So for this one, what we would have to do, 4 limits. I don't want to do that. Okay, I don't want to do 4 separate limits. You can if you want to. It's just fine, but it takes a long time. So what I'm going to do here instead is I'm going to try to find a formula for, I'm going to try to find a formula for f prime of x. So what my goal is here is if I find out that f prime of x is equal to like 7x, it's not, but let's say it was. Then what would f prime of negative 1 be? Well, it would just be negative 7, right? F prime of 2 would be 14, f prime of 6 would be 42, and f prime of negative 5 would be 35. So if I can find a formula, this is really valuable because then I can just plug in the numbers one at a time. So I wrote this down before, but we're going to use it a little bit more specifically here, so I have it written down. I have it typed. If you want to find f prime of x, you just do the limit instead. The only difference is that I changed the a's to x's. So I'm not going to use a specific value. So no specific number. We're just going to use x. Okay, so no specific number, we're going to use x instead. So what we're going to do here, we're just going to plug it in. So f of x plus h here is just x plus h squared minus f of x, that's just x squared. So limit as, this should be h approaches 0. That's what I get for copying and pasting. So limit as h approaches 0, x plus h squared minus x squared over h. That is the limit as h approaches 0. Now we got to expand it out. So we got x squared plus 2xh plus h squared minus x squared, all divided by h. People get scared of the x and the h. Just do it. It's just algebra. Just make it happen. The x squareds cancel. Now we share an h on the top. Like I said, that'll always happen. So limit as h approaches 0, h times 2x plus h divided by h. The h is canceled. That's the magic step. Now I can plug in 0 for h. This is equal to 2x. So what does this mean? What this means, if you think about the parabola x squared, there we go, and you want to know the slope at this point, or this point, or this point, as long as you know the x coordinate, 3, or maybe like negative 1, or negative 4, something like that, you can get the slope just by doubling it. So at 3, what's the slope? 6. At negative 1, the slope is negative 2, and at negative 4, the slope is negative 8. Right? That's it. So if I want to know all of these, I just plug them in. So negative 1 is going to be negative 2, 2 is going to be 4, 6 is going to be 12, and negative 5 is going to be negative 10. That's all there is to it. Cool. Alright, got one more, because this one's a little bit tricky. We're going to do it with 1 over x. We're going to find the equation for f prime. So we do our limit. H approaches 0, f of x plus h minus f of x divided by h. So we're using x's again because we don't have a specific value. So that's going to be limit as h approaches 0, 1 over x plus h minus 1 over x divided by h. We need a common denominator. So we do x plus h up and down stairs here. Here we do x and x. So we have limit as h approaches 0. Looks like x over x times x plus h minus x plus h over x times x plus h, all divided by h. Now I'm going to write that as times 1 over h. We did this before, right? As opposed to dividing by h, because I think it's just easier to do it this way. So that's limit as h approaches 0. Combine the top here. Remember, this negative distributes to both of these. So we have x minus h, minus x minus h, there we go, divided by x times x plus h times 1 over h. X's go away. What am I left on the top? Negative h. Do not drop that negative sign. Limit as h approaches 0, negative h over x times x plus h times 1 over h. The h's cancel. That's the magic step. So we have limit as h approaches 0, 1 over x times x plus h. Now we can plug in that 0 for h right there. And we get, sorry, I dropped my negative. Didn't follow my own advice. We get negative 1 over x squared. Now before, remember we found f prime of 3. We got negative 1/9. Which is exactly why, right? You square the 3, negative 1/9. That's what you have. This makes sense to me because the slope of any line on this function is always going to be negative. Doesn't matter where you are. This function is always decreasing, so you always have negative slopes. I believe that was the last one. Yep. I love you guys. That's why I'm here. Have a great day.